Um, okay, so this is going to be the third stream we're working on the ecosystem project, which we do have some ideas for like what to do with it. Let's see, code, builds, nature of code and Rust, and then right, just that. Open this up in code. Actually, not the entire thing. We want the ecosystem project specifically. That we can open up in code. And let's see where we left it. Right, so we have different sizes based upon how nutritious these foods are. And we lose, our walker loses health just over time as it walks, which isn't necessarily the best. I don't know. We have some of these ideas. So in our README, we have the idea to kill the walker when it runs out of energy, so that way it goes completely away. Hello, Miguel. Good morning. Um, just and then let's see. Start with less food, but add food every X ticks. I like that one too because it's there's just like so much on the screen right now. If I start with like less, but then continuously add it, that might be nice too. And then we could even limit how much food we have so we don't like get too much. And then use delta time. So delta time, that's we have used it before here. The main idea for delta time is instead of having to do things like we're going to move at 0.00001 pixels per tick, we can just say like it has a speed of 57 or 150. And delta time will basically scale that down to be appropriate per tick. I think those three are good things to implement. Now, Katali did suggest last time scalable energy used based upon size, and Crossbow mentioned move faster as smaller. I can see both those things, but I'm also like a little bit hesitant to like add those in as well right now. Maybe later on we can. I had also gotten an idea of adding in some kind of reproduction system, where so that is same type touch each other, new one appears. That way, sort of like they could try to keep the population alive, and now it's population versus population. That might be interesting to eventually one day do. I am not going to do that today, though. So with that, let's kill the walker if it runs out of energy. So in random walker, we don't have this idea of like storing the energy inside. I think that we should start doing that. So basically say, okay, we have an energy, and maybe everyone starts with, this is going to be an F. This should be an F32. The reason why I'm thinking this could be an F32 is I can reduce it by fractions of an amount. So instead of like a full 1 minus, I can remove it by like 0.01. Okay, so everyone starts with 100 at 0 energy. And when we walk, now our sizes is like we're reducing the size. I'm thinking maybe we keep the size the same, but the energy changes. Oh, and you know what we could do? We could. I want to go see what the what the rules for GGEasy's from RGBA in graphics color. Let's see, I need chromium. Because what if we, instead of making them smaller as they get weaker, we just make them fade away? So what is that? Creates GGEZ. Okay, so alpha component fixed to 255. Does that mean, let's see. I always forget. Opaque is fully there, and 0 is essentially invisible. I think that's how it works. So maybe we should start with this would be a U8. So we'd have to go with U8 here as energy. And set, oh, U would be 255. U would be a U8. And then when we create the color for this, in draw, oh, so color here is actually being created once at the very beginning. I'm thinking now we're going to want to change that. So instead of color like that, maybe we'll do something like red U8, blue U8, green U8, RGB, so I'll move you up. Okay, so we're making this white for right now, so they could all be 255. We could eventually make this like random for when it's being created for what color it is. We could also do something like pass in what like the base color will be. And that means this color is no longer there. Whoa, I locked myself. That's not cool. Okay, give me a second. Katali, hello, good morning. I was using the wrong password. Okay, we're back. So control, not Windows key. Okay, that gives us what the color will be. So now here, instead of self.color, we can create a new color here and just use it. So I'm thinking color new from RGBA, and we'll do self.red, self.green, self.blue, and self.energy. And that will be like it fades out as it goes away, which means the size is just going to be whatever like the base size is, but the energy will go down. So self.energy. Now if I subtract 1 every frame, that's sort of like, it kind of sucks, doesn't it? Because every frame it's gonna be yeah, I think what I really want to do is have a lose energy. Like a lose energy function. Maybe like a spend energy. Why am I using a single variable for each color instead of a color variable? Well, so the reason why I'm thinking about that is I want to change the alpha. And that's an interesting question. Can I change the alpha separately no, because I can't like update the color. Maybe there's something I can do with let's see. Maybe there's something I could do with what is it called? Draw. It's these params. What goes into params? Into drawable param. That params equals params into. Oh, color to RGB and then the alpha. Oh, I can do that, huh? Eee, that's cool. That's a lot better than what I was thinking of. So if I do color, 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 color from, I guess this would be RGB. So we'll do 255, 255. And then here, so color from RGBA. And then this one will be self.color.toRGB. It doesn't like that. Oh wait, you're doing double colons. Good morning, Skarsh. Double colon. So is there off of color? Can't I spread it? Wait, is there spread in Rust? I haven't looked at that before. No. Don't trust your double colons versus dots. Okay, so let's take a look at this. Oh, wait, that's graphic still. Where's my color? So implement rect. Okay, so here's the public struct color. Oh, so it's a pub R, pub green, pub alpha, pub blue. So I can just do self.color.a, self.color.r, self.color.g, self.color.b. That's what I can do. So self dot color dot r color dot green self dot color dot blue. So that mismatch types found U8, expected U8 found F32. So that's a problem. They've converted it. Well, you know what I could do is just do new, color new. Yeah, exactly. So you just become new. Self to energy stops being a U8, and this becomes an F32. And we'll just start with 1.0. You're fully there. Now, as we go down, so I want to spend energy. Not going to return anything. We're just going to say self.energy equals self.energy minus 0.01. Like just a very small amount. Okay, so that's walk. Now this is having it move in the correct direction. We have its eating. In our main library, we have our random walker here. So we have it walk, we have it eat, and then the last thing we want it to do is we want to have it see, walk, eat, and then what is that called? It's going to be a to lose energy, but only on certain number of frames. So I can actually get the frame count. I think that's under timer. So in timer here, I can say timer ticks. So timer ticks gets the number of times the game has gone through its event loop. So this number is going to go up. It's going to be a U size. But I can basically just count and do a okay, and then I just pass it context. Not underscore. I want you to stop being underscore now. Oh, this is lowercase. I probably wanted to use GGEZ timer. You don't need to be in here. And so in you, we're going to do if GGEZ timer ticks past the context, if that modulus. So let's store how many ticks per energy lost. This can be, it's going to be a U size. Maybe we should do something like, I don't know, we'll try 100 for right now. And so I can say, if that modulus self dot ticks per energy lost, if that is equal to 0, then self dot random walker dot spend energy. That should make it fade away over time. So let's try running that. Now I don't know if 100 is too fast or too slow. Kind of also was expecting to see it going down a lot faster right now. But maybe like 100 frame ticks combined with like 0.01 is just too slow. The other thing I realize is when it gains energy, it should go back to full health. It gets a stay of like, death. Is that getting dimmer? It looks like it's getting dimmer. So I think it is working. I do want it to last a pretty significant amount of time. Now, the other thing is like if we are making it grow bigger as it eats, I do I want to like make it shrink then? Crossbow, good morning. Hello. Yeah, it's definitely getting dimmer. I'm not completely sure that now that I see this that I like it. I think I do like the idea of making it get smaller, but just make that really, really, really slow. It's still spending energy while eating. Yeah. Well, right now it is. I could have it reset the energy every time it eats. Yeah, that's what I was thinking. Like now that I look at it, Miguel, I think I do want to do that. Is make it get smaller. Instead of fade, just use the size again. Shrink with energy use. Bigger with eat. Yeah, I like that a lot more. Because right now, it will just get infinitely bigger. I'd have to be able to figure that out. Well, basically, what I have to do is make it not grow, which that sort of stops that from working the way I want it to. So, okay, undo time. We are going to let's see. Now lose energy. Spend energy. That can be the same here. We can still spend. What happened to it? Did it fade away completely? That was pretty. I wasn't paying attention for just a couple seconds, and now it's gone. All right, so we're gonna spend energy. You played with the code. You think the walker is too many times stuck in a corner or walk only in edges. Yeah, that's having it like move and go across would be better. We could maybe fix that. Let me add that to fix that too. So wrap the screen so walkers always are never stuck on the edges. I think that is a good idea. I think that's something to like invest in. All right, so I love how like it ate everything down here on the way down. So we're still gonna have energy. Our color can once again be created up here. So this is gonna be color from RGB. So 255, 255, 255. Wait a second. You are just color. You are. Actually, I already have that. When I draw you, color is just going to be self.color again. So I'm thinking spend energy can again be just sort of subtracting down like this. Energy is an F32. Our size is going to be based upon the energy. Oh, you make the change where color is calculated in size? I had thought about that. I think Miguel is right though. That we can maybe not energy here. So we're going to start with size. And we're going to eat down. So this is going to go down by 0.01. Size. And eat will make our size go up. Lose energy will make our size go down. And when we draw, our size is there. Yeah, that's what I'm thinking, Miguel, is with each chapter we're gonna get a different type of walker. And so that's gonna give it the colors are gonna be the personalities. So like this is a very dumb simple walker. It's essentially gonna be Bray for all the other walkers. If it eats, it's only accidental. The other thing that I notice, I think it's oh, you make color for food, not for walker. Like the different foods are different colors. I was thinking maybe eventually I could create poison foods that would also like vastly shrink you as the walker down. That might be really interesting too. So that way, you know, this walker is kind of dumb. It just eats everything that it comes across. You know, something else would be nice is if I could split this into half the screen. So whatever this is, that's what I want. That's what I want that's what I want it to be. So that way I could just have it going and take up the full right of the screen. Maybe a little bit down here and just come close to where I am at. That might be good too. Or I can do something like this and just have it go down. Yeah, I was thinking about red as a poison food. But I don't know if people are red green. Is there a red green what is it called? I forgot the name for it when you're color blindness. Is there a red green color blindness? Because if there is, then it would be very difficult to see. We could also make different shapes. There's all sorts of things that we can do with that. Oh, okay, there's red green color blindness. So not that. So let's come up here and we'll just we also want poison food. Probably different shapes for food types. And also not just circles, just like our walkers are. And so wrapping the screen. All right. I keep on adding more features for this thing. All right, so kill the energy when it runs out of it. Also, this doesn't seem to be shrinking very much, does it? Like I don't see that shrinking. I know it's doing. So it's spending the energy and the size is going down, but this might be just by too small. So if I make you like that, colors with different like pureness isn't that bad. Is there a simulation? Or do any of you have red green color blindness? Because I don't know exactly what that would look like. I don't know if there's any simulations for that I could look at to sort of like see what that would be like. Okay, so this is shrinking now. Your father and your uncle are colorblinded. Okay, so you're very much aware. So you seem to be shrinking not too fast, which is exactly what we want it to be. And so what we also want is for it to die. So if it shrinks and its energy becomes essentially 0 or less than 0, so its size is this. So I want to make you public. I mean, either public or maybe a better one would be just to have another public function. So pub function is dead. This will return a boolean, and so we're just going to return that self dot size is less than or equal to 0. And then our library. Right now we just have it in here, so I couldn't really remove it, could I? You know, eventually I'm going to want to have a vector of these. If I use, how could I have a vector of different types? Because like this is a struct of random walker. If I wanted like, this random walker, let's say I have like a completely different one, so I create a new struct for it. What would that look like? I can't do a generic vector, right? Because that still has to be one type in the vector. Vectors can't hold multiple types. You'll show them the end result, and okay, well in that case, let's because if you're gonna show them that, let's add that in where it's random if the food is red or green. So I think I have a food. So here's this color. Color is just purely here. We have our RNG. What I think that I can do is say, let color. And then, oh, you know what? Okay, so let color equals, I can do an if, I can do a fun if here. So if RNG dot, oh, there's a way to do it. Create a vector of colors and randomly choose one of them. I could do that, or I could just create, there's a way to get a boolean out of this. And I forget how, but it's like right on this front page. Okay, so random generates a Boolean. Okay. I don't even need to bring in RNG. I could just use random. So I already have this. Okay, so if random, then we're gonna return into here color from RGB. So our red is gonna be 255 0 0. Else color from RGB, and this is gonna be 0 255 0 and semicolon there. So this will make it random between red and green. I like how it's negative size now, so it can't eat anything. And there we go, random between red and green. You need to make a new enum with different types and use that in the vector. Ooh, yeah, that's a really good idea. So what would that look like to me? If I, well, okay, I also want to kill this when it gets dead. Oh wait, no, I can't do that right now because I need to like set that up. So, all right. So struct random walker. Let's create a new enum. I guess so. Like this will be like a basic walker. Of type. What did I wait? Wrong. Not here. In live. So walker. We'll have a basic walker, which is a type random walker. Is that how to do it? Okay, no, it's parentheses. Well, let's try it, Crossbow. Let's see if this works. So it likes this, and so then I could have, instead of random walker here, I'll have walkers, and it's going to be a vec of walker. Okay, so far. So instead of random walker like this, so this will be, okay, let walkers equals a vec. And so the first one that will go in here is this one. And this will just be our walkers. Oh, mismatch types, right. So you need to be walker. Is that parentheses? Oh wait, it's not gonna be walker parentheses. It's gonna be walker colon. Nope, not that. Basic walker parentheses. Okay, so there we go. So that stores that. So then we have our walkers. Now I need to iterate through the walkers. So that's going to be self dot for walker in self dot walkers. Now I want to run these methods off of each one, but this is also the enum, so I need to extract it from the enum. How do I? Is that an if let? I think it is. So if let's see, what is it called? Walker, basic walker. This is gonna be a random walker, or I'll just call it basic walker equals walker. Then I do these. So you're gonna do basic walker dot walk RNG self dot window width self dot window height. Okay, so that works there. So I can just move you all in, So you'll be basic walker dot eat. Oh, it's not happy. Am I expected bool found? Ooh, okay, so that's. Oh, yeah, it's stuck on the left edge. It's also probably like negative size now. Okay, so this is a problem here. Expected a Boolean, found just parentheses, nothing. So self.walkers, so we are going through there. But this, try comparing for equality. Oh, if let. I forgot let. And not there. Here. All right, see, there we go. If let walker, so like set if that is what this is, set that in here. And you become a basic walker too, and it'll spend energy. Now I think when we create the second type, we're gonna have to like redo this. I think at that time it'd be excellent to extract this out into maybe generic, like generic function that can take in any kind of walker and run these functions on it, which means we'd have to set up traits and all sorts of other stuff, which is what we want to do anyways. Right now we only have this one type of walker, so I am not going to worry about it. I'll leave that for future me to deal with. I'm sure future me will be super happy with that. We're going to need to do the exact same thing here. So we're drawing all the food, and then we just draw the random walkers. This one will be, it'll still be the same problem. So for walker in self.walkers, if let walker, basic walker, equals walker, then we move you up here. Oh, and so we need to draw this like that. So we created the random walker. basic walker.draw. That way you can use a reference to it. Irrefutable if let pattern. Is this a warning? Or is this it's a warning, right? Oh, I have some errors in here too. All right. So this is the basic idea, but we have some problems in here. We have some reds. So you cannot move out of here. Because, okay, I don't create the copy trait for walker. So can I borrow you? Oh, I need to turn this on. That way you can show it. I'm not. Is it double equals? You might be right. No. Okay. It's not for an if let. It is just pure equals. Never mind. All right. So what's next on our problem list? Cannot borrow basic walker is mutable. It's behind a at reference. Oh, I need it to be a mutable reference. And same here. Yeah, if you just have the if, then it's double equals. Okay, so irrefutable if let pattern. What does that even mean? Oh, is that because like this is always going to be the case? So it's just letting me know that I don't really need to do this. I think you're right. It can only be the basic walker. And so I think if I was to create like a completely different type of basic walker, then this would be happier. And then finally, we want to check to see if dead. And if dead, I want to remove it from the index here. Oh, your video stopped and you weren't seeing the let. Oh no. And then finally, I want to call if dead and then remove it from this vector. Remove it from the vector. Is dead. Yeah, let's see. So if I run is dead, you know, I realize I don't have the index. So I'm gonna have to search through this. Maybe you can ask me this while I search for it also. In a hash map, can I have different types as the values and keys? So like with the name of it or an ID or something being, no, it has to be the same type? Oh, okay. No, but I could use the enum. So I can use my enum system, instead of an vector, use a hash map. I can insert the name of it and then the value. Right, because I have to give it the key type and the value type. And they have to be the same. You know, is this also the reason why like boxes would be really useful for me? Because if I use like a box type, then I could wrap those in and they'd be different types? Or is that a completely different use case? Also, viable clan member. I didn't notice. I didn't see that you were here. Good morning, and DBC. Good morning. Key and value don't have to be the same type. I think they do. Like according to this, don't they? Well, there's a really easy way for us to do this. We can go to the playground. Oh, look, here's our last playground thing that we were doing. All right, so we want to pull in use standard collections hash map. I want to create a new one. So let mute map. All right, I'll just call it my map equals hash map new. So that will just be that. Then can I put in insert different things? So my map dot insert. So if I say like hello goodbye, is that a question mark? No, it's just gonna work. Also, this would need to be a toString because those are stirs. So there's that. If I not okay, so it's happy about that, and then if I want to get that out to print, so there's a length, there's remove, there's there's get. Oh, that gives you an option, so I could like unwrap that. Oh, can I just debug print? Would that work? Hey, okay, so debug can print hash maps. Cool. Okay, so I have that. Now, can I do this? My map dot insert another and then have this be something like just 42. No, okay, so it has to be a string here. Now, can I say my map, hash map? Can I tell it what type I want? Like, would that be here or here? Why toString if they're already strings? Well, I guess, do I want them to be strings or strings? Like, there are the two different types of strings. So, the string here is going to be on the stack. No, not on the stack. On the heap. On the heap. And so that just makes it a little bit easier to use and growable. And then stirs, which is what these are, is actually just like fixed. Again, not a problem. I could leave them as strs. But if I wanted to like take in user input and like grow something else, I'd want to make them strings. Now, can I do something like this? T, Y, and to make them generic types? Definitely not that way. Not that way. Okay, so it doesn't like that. Let's see. Now, I guess the other idea that we had was if we use an enum, and we basically have our a string. Miguel, you left and like everything has changed. So I'm trying to figure out how to properly remove. So when I kill the walker because it runs out of energy, I need to remove it. Well, I realized I don't actually have like know where it is because it's a vector and the vector is going to change. That means it's going to be harder to sort of see. If I were to give it a key and value, my map, oh, is Hashmap. Okay, let's try that. My map. Then I'd be able to go in and just say, hey, here's the key, and then kill it. Just remove that. So let's try Hashmap T Y as its value here. We're gonna not use you. Oh man, I don't even remember how to use generics. Generic hash map. Does this talk about generics in here? No, it doesn't. Yeah, I think the idea here is that I'm gonna have to use an enum. What I want to do only works with enums. That makes sense. Okay, so I'm gonna say, not gonna say you. Okay, so enum. All right. Enum, and we're gonna have like I don't know, first, second. So our first insert, we can just have like one. So I can just use this as like 1 and 2. Give it IDs like this. Our value is going to be for this one. I need to give this a name. So like, I'll call this values. And you are also going to be a like an F32. And let's say like a U size. So I need to be able to extract out the values from this. I need to be able to remove it. I need to do all the cool stuff. So if I, this will be values first, like 15.0. And you, insert would be like 2 values second, and like 23. Oh, the values. Okay, so now it can't display this at all. A hash map with ID and robot number. Yeah, that can make, well, that would make sense, right? I would give it a I would create a unique number for each walker as I create them, and then add that, and then I could delete for the ID. Exactly, yes. Let's see. So I need to implement derive debug. On my hash. Oh, for values. Okay. All right, so that would work. And then I could now get. So what is this? If let some value equals my map dot get 1, then print line value. Oh wait, no, I'm just gonna debug value. So it should come up first. Expected a reference to integer found integer. Borrow the integer here? Yeah, that worked. Okay. So then I get this first value here. And then I could maybe manipulate that. I think that's how it would work. So this entire system would work here. So let's do that. So standard collections hash map. We need to bring that in. You sort of died. And then yeah, I'll need to get mute with that. But so let's start with that. So use standard collections hash map. Our walkers is actually going to be, oh, here's where I can set the type. So this can be a hash map of type. I'm thinking an unsigned U8. I'm not going to have very many of them. And then the other one is going to be a walker. Okay. So here's our walkers that we're creating there. And so walkers is going to need to be a, oh, we're going to insert these. So let's just start this over again. So walkers is going to be a hash map new. Here's our walkers. Then I need to insert as I create these. So we'll have another for loop. So for index, is going to be index. It's going to be like ID in 0 ... Let's like create 5 of them. Then we'll see them like going down. And okay, so for ID in 0 to 5. Now we're going to say walkers dot insert. Our key is going to be the ID, and the value is going to be our random walker. Oh, it's random walker new. So here we can do window width, window height, our mute range, thread range. So that's just going to be RNG. I think that needs to be a reference to it. And we need our ID. Oh, and it can't be just a random walker like this. Of course, I keep on forgetting. It needs to be a walker, basic walker in the enum. Now this is complaining because I've added in the ID here. So let's go back to random walker and add in an ID, which is a U8. You truly hate the gray text boxes. Oh, you mean these? I think they can be changed in those can be changed in the themes. I haven't really looked at any good themes recently, so I might want to update those. Okay, so that gives me that. Everything else should be good now. We have 3 errors. Oh, so it didn't want. It just wants that. 2 errors. Okay, so now these need to be updated. So for each of my loops here, we need to iterate through the. I basically want to sort of like redo this. So I'm gonna comment you out. I need to iterate through the hash map, and I know there's ways to do that. Hash map, is there like an iter? An iterator visiting all key value pairs in arbitrary order. Okay, that's exactly what I want. With mutable references to the values. So that's what I want here. So an iter mute. Okay, so let's try iter mute. So we're going to say self.walkers.iter mute, which means I want to how does that? Okay. This is the key. This is the value. So I will want the key in this one. So it's a tuple. So this is going to be the ID and the walker in self.walkers.iter mute. Now I can do, so I'm going to have the walker, which is going to be the enum. So now I have to do this if let inside of here. So that's, you essentially come in here. And I'm going to say, okay, so if let walker, basic walker equals the walker, then basic walker.walk. So then the same thing here. So like this should walk, this should spend energy, this should do all those things. And if you die, So you spend energy. After you spend energy, we can say if basic walker dot is dead. I don't like the fact that I've like tabbed this in, but I think when I call a function in handlesyn, it'll be a little bit less terrible. Okay, so if the walker is dead, then I have access to the ID. I want to now remove this from walkers. So we're gonna say self.walkers. Removes a key from the map, returning the value at the key if the key was previously in the map. And it's going to return an option, so I don't really care about getting that back. The key may be any borrowed form of the map's key type, but hash and equal on that. Okay, so equal. Okay, so dot remove, and it's going to be a reference to the ID. I know I'm removing the item while iterating over it, which this seems terrible, but oh, it's not liking this. Wait, nope, it decided it did like it. And then we need to do the same thing down here. So it didn't decide that it hated it, which I'm actually kind of surprised about. I expected this would be very upset with me. All right, so we're going to do the exact same thing here. So I'm just going to copy you in right here. And so instead of all of you, we'll just do these two. And then you go away. Of course, we have the same problem there. Now what's cannot borrow walkers is mutable as is not declared mutable. All right, so where is that? For ID in 0 to 5. Oh, walker, so you need to be mutable. Cannot borrow self.walkers is mutable more than once at a time. Ooh, okay, so where? So where's the first time I'm doing that? Fuse mutable borrow occurs here. So we borrow it mutably here. And second borrow, oh, so we're borrowing it here again to run the remove. Oh, right, because it's borrowed and intermute. So yeah, this won't let me do bad things, Danny. You're right. So what I really need to do is create in here well, I have the is dead. I can't really iterate over it, can I? I'm gonna have to create some kind of storage of the IDs that I need to delete and then go over them and delete them later. Because I can't really remove them as is unless there's like a map function. Is there map in here? Well, so there's intermute. If I go into intermute, is there like a map? I don't see that. Well, there's also just iter. I don't see a map here either. So I think if I'm wrong about this, let me know. Otherwise, what I'm thinking I need to do is store the I guess not here. I could just do this all in, and this doesn't need to be part of state. This is all part of update here. So what I can create is let IDs, like dead IDs. So an empty vector. And so instead of removing this like here, if basic walker is dead, then we're gonna just dead IDs dot push the ID. Okay, irrefutable if let pattern, but what are you, so cannot borrow dead IDs as mute, okay, yeah, so that's just me forgetting to make the vector mutable. So that's cool, and then down here, we can now for over, so for dead ID in dead IDs. Up, I need to go close the door. My wife began blending downstairs, so if I don't have the door closed, that just comes right up in here. Okay, so we have the dead ID and dead IDs, and now we can remove. So we can say self.walkers.remove reference to the dead ID. Cannot borrow self walkers as mutable more than once at a time. Wait, aren't I doing it separately now? First mutable occurs here. Okay, I get that, but this is not in here anymore. First borrow later used here. Maybe I can't get it. Well, I guess self.walkers as mutable more than once at a time. Second mutable borrow occurs here. So it is upset about self.walkers. So I borrow it and then borrow it mutably. Using it mutable is a consumption. Okay, so it's gone. It's dead. Then how do I, if it's gone and dead, assuming Hashmap returns a lifetime. All right, let's go take a look at how see, so we're still in Hashmap, intermute. So this updates all the values. And they're still using it. Oh, but they use a reference. Can I just use a reference in it? Oh no, because like I am using this mutably here. I'm also I've run out of time. I have to start getting ready for work. So I'm probably gonna have to just leave it at this. the problem obviously is that we can't do this. It won't let us. I want to just run this through really quickly and see what the full error message is. Wait, is the problem self.walkers? Or just this? No, it's still self.walkers. Because like this sort of feels weird. First borrow, later used here for this code, because I'm not touching walkers. I'm touching the dead IDs. Well, so this idea didn't work either. I'm gonna have to think about this a little bit more. Why exactly do I need to delete the walker? You want to know whether or not it's dead? Well, okay. I would love to be able to like create new walkers as time goes on, or we could just leave it running until they all die and then restart the game. I don't have to remove the walker. I guess I sort of got into that loop because I felt, well, for proper memory consumption, I should remove it from the hash map or the vector or whatever as soon as I'm done with it. And then I don't have to like worry about that anymore. But if I can't actually remove it easily, then I'll probably just leave them in there, and then we'll just have this is dead, and then we'll have to like put a, okay, well, if you're not dead, then go ahead and do this with it. Which is a little bit sad, but we'll have to consider that for next time. So until then, I'm gonna close all of this down. Trying to loop over multiple walkers and remove the dead ones. Yeah, but there's the it gets a little bit interesting with like the borrows. And when you say container, are you thinking of something like a box to like hold each walker in? Because like the borrow I'm running into is not the walker itself, it doesn't look like, but the hash map that holds the walkers. I wonder if a walker's struct would be better. And then I could create my own iterator to sort of like go through them. I don't really know if that's exactly like what I really need. I'm gonna have to like let my subconscious think about that. Until then, I have pushed this up. Let me give you all the code. Here is a link to the code. I'm gonna go get ready for the rest of my day, and then hopefully we'll figure something out, and then Friday when we come back to this, we'll be able to actually implement killing off the walkers and do that. But until then, have a great day and a great rest of the week until Friday. All right. See ya.